Hello my dear students, let us continue our discussion of the entrance method for solving the type linear biquadratic, or let us say linear by root quadratic also. Let's take the first example in this. We have to evaluate and we have to mark the correct option for the integral 3x plus 2 upon root of 2x square plus 2x plus 1 dx. Now my dear students, let us begin with our analysis. If you see again, every option here has 3 by 2 root of 2x square plus 2x plus 1. So my dear students, there is no need to evaluate the first part, which is nothing but p upon 2a. So let me put this directly here. This is same in every option, so it has to be a part of the answer. Now my dear students, let us recall the shortcut says it is p by a root of ax square plus bx plus c. You can verify the shortcut also. P in this case is nothing but 3, q is 2, a is 2, b is also 2. So if you see p by a is nothing but 3 by 2, which is very much clear. Now what I need to do is find the value of q minus pb upon 2a. So let us evaluate that. That is nothing but 2 minus of 3 into 2 upon 2 into 2 into I1. So obviously if you see the calculations here, 2 gets cancelled. So we get 2 minus of 3 by 2. That's nothing but half. So can I say this is nothing but half of I1? Correct my dear students? So let us see what is I1 equal to, or how to find I1. Now I1 is nothing but integral 1 upon root over 2x square plus 2x plus 1, which we will write it as root of 2 common x square plus x plus 1 by 2. Now my dear students, you are also very clear that to solve 1 upon root quadratic, we need to make coefficient of x square as unity, and that's the reason we have taken 2 common. Now you also know that in the next step we will take this to outside the integral. So what we'll have outside the integral is nothing but a root 2. So I'll get 1 upon 2 root 2 integral of 1 upon root of something. Now why I'm saying root of something? Because I'm least interested in what I'm getting after this, because I already have the answer. And what is the answer? There is only one option, which is option D, which is having 1 upon 2 root 2. So I can very confidently say the final answer here is option D, or I can say options A, B, C are wrong. And that's how we complete this particular sum. Now my dear students, there is no none of these in these 4 options, and therefore it can be directly assumed that option D is the answer. Okay, let's take one special integral now. Now what's so special about it, or why do we call it as a special integral? This type of integral, which is integral of 1 upon linear into root of linear. Let me repeat again for you. 1 upon linear into root of linear. This type of integration is not usually asked in the board exam, but you may expect this in the entrance. Now if such a case is asked, what is my method? The method is very simple. You have to put root of linear is equal to t. That means out of the 2 linear expressions, the one in the square root has to be substituted. So let me write that explicitly for you, that let us put px plus q is equal to t square, or root of px plus q is equal to t. That means px plus q is t square. Correct? Let's take one example based on the same. I have integral 1 upon 2x plus 3 into root of x minus 4, and we have 4 options. So now if you very clearly understand, we have just seen some time back the method for integral of 1 upon linear root linear, and the method says what? The method says substitute root of linear is equal to t. So in this case I am going to write x minus 4 under root is equal to t, or can I say x minus 4 is t square? So if x minus 4 is t square, can I say x is equal to t square plus 4? Correct my dear students? Now can I differentiate? Dx is 2t dt. Now my dear students, let us give effect to these changes of these things in the integral. So the integral will become, the numerator will become what? It will become 2t dt. The denominator will be 2x plus 3. Now 2 will be as it is. In place of x, we will write t square plus 4. The plus 3 has to follow. Now my dear students, root of x minus 4 is nothing but t. So let us put a t here. You can see the t in the denominator, which is outside the bracket, and t in the numerator will cancel. So now the integral will have 2 upon If I multiply the 2 inside, I'll get 2t square plus 8 plus 3. So let us check that. That is 2 upon 2t square plus 11 dt. Is that okay, my dear students? Let us take this 2 outside the integral, or let me keep it here, and take a 2 common from the 2 terms in the denominator to get t square plus 11 by 2. So we have t square plus 11 by 2. Obviously these two will cancel out. Now my integral can be written as 1 upon t square plus root of 11 by 2 the whole square. Is that okay? Now this is very much of the form 1 upon x square plus a square. My dear students, I already told you in the earlier models, whenever it is plus in the denominator, answer will be in terms of tan inverse. So let us see that formula. 1 upon x square plus a square, the formula is 1 upon a. So let us put that. Since it will be root of 11 by 2, which is my a, I am very clear that option B and D are not the answers. 1 upon a means 1 upon root of 11 by 2. 1 upon root of 11 by 2 means 2 by root 11, and 2 by root 11 is present only in option C. So option C is my correct answer. I don't have to write every step in entrance. I just need to know the 3 wrong answers or the right answer. So which is in this case is nothing but option C. And this is how we solve entrance. That's all we have in this module, my dear students. Thank you very much.